So far, we have learned the embedding concepts. We have also learned how word-to-vec models are trained. We have also trained our own word-to-vec model on our small text corpus. Essentially, when you are developing your real-world use cases where embedding is needed, you don't need to pre-train your own embedding models. Instead, you can make use of the available models which are there in the market through open source community or through paid service providers like OpenAI and Google Bard. So in this video, I'm going to provide you what are all the embedding models which are already available in the market which we can make use of during our use case implementations. First and foremost, let's explore the significant breakthroughs in embedding technology throughout history. The bedrock of many embedding models, including those accessible via open source platforms, is rooted in these technological achievements. Consequently, when coming across or employing pre-trained embedding models on platforms like Google Cloud, Azure, AWS, Hugging Face, OpenAI, and others, it is reasonable to infer that they are constructed upon these fundamental technologies. There are several popular pre-trained models published for general use. Word2Vec. This model was published by Google in 2013, and I would say this was the major breakthrough in embedding. Word2Vec is a neural network based model that learns word embedding by predicting the context word of a target word within a large corpus of text. Then Glove. This model was published by Stanford Research in 2014. Glove, which stands for Global Vectors for Word Representation, is a count-based model that constructs a co-occurrence matrix of words and uses matrix factorization techniques to learn word embeddings. Fast text. This model was published by Facebook in 2016. Fast text is an extension of Word2Vec that uses character n-grams to learn word embeddings. This allows the model to learn out of vocabulary word and rare words more effectively. Elmo. This model was published by researchers at Allen Institute for AI in 2018. Elmo, which stands for Embeddings from Language Models, uses a bidirectional language model to learn context-dependent word embeddings. BERT. This is again was a major breakthrough. This model was published by Google in 2018. BERT, which stands for Bidirectional Encoder Representation from Transformers, is a transformer-based model that uses a masked language modeling objective to learn context-dependent word embeddings. SBERT, which is Sentence BERT, which is a modification of BERT network using SAMSE and triplet networks that is able to derive semantically meaningful sentence embeddings. OpenAI model text embedding ADA, which has different versions. The latest one is 002. The ADA embedding model is designed to address some of the limitations of traditional word embeddings, such as the inability to handle out of vocabulary words and the lack of sensitivity to morphological variations in words. ADA addresses these limitations by using a subword encoding scheme that breaks word down into smaller subword units and learns embeddings for those subwords units instead of full word. The ChatGPT uses this. Input token limit of ADA is now 8192 tokens, making it more convenient to work with long documents. Embedding size. It has only 1536 dimensions, 1/8 the size of the DaVinci model which they had earlier, making the new embedding more cost effective in working with vector database, because the lower the dimension, your vector database cost is going to reduce. Then Google's text embedding models. Here the input token limit is 3072 and output embedding dimension is 768 dimensional vector. This table not only lists the names of popular embedding models, but also includes information on their supported dimensions. architecture behind it, categories, whether they are open source or not, and who published these models. Sentence Transformers is a Python framework for state-of-the-art sentence, text, and image embedding. The initial framework is described in this paper. The framework is based on PyTorch and transformers. It offers a large collection of pre-trained models tuned for various tasks. This list is not complete. In fact, it is a growing embedding model repo. So one can go to this repo URL to see the latest models. So this is the URL of sentence transformers, and this is their model repo. You can enable this all model, and then it provides you the list of all available embedding models on this repo. In this table, along with model name, it also provides different performance numbers, also provides the model size. I myself have explored a couple of embedding models from this repo, and the results were encouraging. On Hugging Face, a plethora of open source embedding models awaits exploration. I recommend delving into the repository to find a model that aligns with your specific needs. In my personal exploration, I have utilized two models, all MPET base V2 and all mini LM L12 V2, and found them to be highly effective for information retrieval use cases. Essentially, in the development of your use case, there is no necessity to embark on the pre-training of a new embedding model from scratch. Instead, you can leverage the convenience of readily available embedding models. Depending on your budget constraints and the specific requirements of your use case, you have the flexibility to opt for a paid provider such as Google, OpenAI, or you can choose from the array of available open source options. This approach not only expedites the development process, but also allows you to select a model that best suits your project's unique demands.